Creating a brick pattern walk for your home is not only a great way to improve its appearance, but its value too. And it is a project for any novice to accomplish. These traditional paver designs can be converted into a paver mold module. For this video, we selected the basket weave design using 8 individual pavers to form the basket weave in the upper right. But by using the outlines on each of the other patterns, you can create interlocking mold modules that will fit together to create each pattern. To begin, I purchased a number of traditional style brick pavers at Home Depot. The plan is to make molds of the pavers, then cast them in concrete to duplicate the pattern. Each mold consists of 8 bricks, and I'll make 2 molds. I calculated that I'll need to make 52 sets in concrete, which I'll color the same color as the bricks with concrete by adding concrete powder colorant to the mix. Here I've cut 2x4s to surround both sets of bricks, spacing the wood 1.5 inches from the edge of the brick pattern. I then screw down the wood in such a fashion that each frames a mold. The gap is important, as you'll see it later. I then remove the bricks for the time being and prepare to seal the wood. For this I used latex gloves, a 3-inch chip brush, and wood sealer, though varnish would be just as serviceable. Once the sealer dried, I then caulked the spaces all around the wood frame using silicone caulk and a caulking gun. Wetting my fingers, I smooth out the caulk and remove the excess with a dry rag. I then return the bricks to the mold box, making certain that they are no closer to the frame than the 1.5 inches I had previously measured. I now begin coating the bricks with the Creamtex liquid mold rubber. I'm careful to make certain that the latex is worked between the spaces of the bricks. This is important so that a clean separation is achieved once we have cast with concrete. Not only are the bricks coated with latex, but the gap between the bricks and the frame, as well as the side of the frame, is also covered. This will result in a rubber flange once we finish our latex coatings. This coat of latex is the first of 14, allowing about 3 hours for each coat to dry. Building a latex mold will take a number of days, but it's worth it, as latex is the best mold material to use when casting in concrete. Overnight, the first coat of latex rubber has dried. The bricks absorb the moisture, so it appears that there's no latex there, but on closer inspection there's a very thin coating. I added the second coat, allowing 3 hours to dry, and I hope to get 4 or 5 more coats on today. I used a fan to shorten the drying time to about 1.5 hours per coat, and at this stage there are about 10 coats applied on the way to 14. But now I have to add reinforcement to make the latex rip resistant and to triple its life. So this time we're going to embed cheesecloth strips. The 11th layer of the Creamtex latex is brushed on, and the cheesecloth strips are cut and laid down on the surface. A coat of Creamtex latex is added on top of the cheesecloth, and the next strip of cheesecloth goes down. I must be careful not to leave any air bubbles or separation between the latex surface and the cheesecloth, or it will be a weak spot in the final mold. I carefully take my brush to the corners and edges and press out all the air, repeating this 3 or 4 times. Once the cheesecloth is down and coated with Creamtex, there will be 3 more layers of latex applied to finish the latex portion. Here the latex is now about 1/4 inch thick, and I'll begin the next phase tomorrow by adding a rigid support shell mold made of fiberglass. But the support shell could easily be made of the cast-right gypsum plaster, but it would need to be about 3 inches thick, and that means it would be very heavy. And since I have to make 52 castings in concrete when the mold is finished, having a lightweight shell mold will make concrete casting easier to handle. I begin creating the rigid fiberglass support shell by first assembling all the materials: polyester resin and its hardener, wax and PVA mold release, a bubble roller and a squeegee, rubber gloves, mixing buckets, mixing sticks and a measuring cup. I'll also need acetone to soak the squeegee and roller in to keep it clean and resin free. And I'll also have a scissors, box cutters, and some rags for cutting and cleaning. I'm outdoors because the polyester resin outer is too strong to use inside. And I begin covering the latex mold thoroughly with a mold release wax. When the wax is dry, I add a second type of mold release, which is a liquid. I paint in a coat of PVA release and allow it time to dry. Strips of fiberglass mat are cut to fit the latex mold and laid on top to wait for fiberglass resin. I mix 20 ounces of polyester resin and combine it with 5.5 cc's of the fiberglass hardener and mix it until the mixture turns a brownish yellow. The resin is then poured on top of the fiberglass matting, and I force the resin through the matting using the squeegee over the entire surface. Later I'll use the bubble roller to roll out any air bubbles that remain. This is the first coat of fiberglass mat and resin waiting to dry. The resin doesn't completely dry in this step. It remains tacky, which helps in the application of the next layer of matting and resin. And I'll put on 3 layers in the shell mold to give it strength to stand up to the repeated pourings of concrete. Once the fiberglass is completely dry, I demold it using a small pry bar that I worked around the edges. The fiberglass shell came free without difficulty because of the mold release. The image shows both the latex mold with its brick pattern and the fiberglass shell. I'll use a saber saw to trim off the 4 edges of each mold. These are very sharp and needle-like, so we have to be careful. And the mold is now ready to cast with concrete.